Sample problems. Look at this one. So you're thinking, oh, you're slapping logs on both sides. I'm just going to do that. Wait, this one already has a log on this side. All right, well, what do I do with this unique problem? Use your noggin. Remember, there's an invisible 10 down here if there isn't anything. So we take advantage of it. We go, hey, I know what to do with this. 10 squared equals, there's my answer, 3x minus 2. Just a bizarre looking start. But then once you get started, you're off to the races. So this is 100 equals 3x minus 2. Add 2, add 2. I get 3x equals 102. Divide by 3, divide by 3. And that is 34. So my answer right there for x is 34. Let's move on to number 2. Now that letter E should be jumping out at you. See how this one already had a log on it, so you couldn't slap another log on it? These don't. But what kind of log are you going to slap on there? Because that's an E, I'm going to slap on a natural log. Now, I got to do it on this side. So here's my 8. Remember, if I went natural log, that looks like N18. So that's why they don't do that. So they're going to go lateral nog. See, I had fun with it. I called it lateral nog. And then what do we do with this? That can come in the front. X plus 2 times. What is the natural log of E? Well, you can take your calculator and go natural log E, but hopefully that's starting to jump out at you as 1, because that would just say e to the 1 is E. So we know that disappears. It's not 0, it's actually 1 equals. Now that, there's no way I'm going to figure that out without a calculator. So I got to go to my calculator, hit the natural log button, then enter 2.079. Now, this doesn't mean anything because 1 times anything is itself. So I subtract 2, so I get x is 0.079. Let's go on to this one. Common bases, happy places. Good luck with that. That's not going to happen. I'm going to slap a log on here. I'm going to slap a log on here, which allows me to bring that down. That's what I want. So I get x times log of 5 equals log of 0.32. I'm going to turn these into decimals. So log of 5 is 0.698. So 0.698, that's an 8x equals log of 0.32, that's a negative 0.494. Divide by 0.698, divide by 0.698, so divided by 0.698. Negative, so x is negative 0.708. Now the book doesn't really tell me where to round it. You could go to the tenths or the hundredths maybe, but I went to the thousandths. Number 4, look at this. So you guys know that you've been doing a million of these where you go, I'm going to divide by 2, divide by 2. Don't lose those basic ideas. Look for it. So I go, I can clean this up a little bit. Divide by 1.6, divide by 1.6. So e to the t equals 100 divided by 1.6, 62.5. Why do you think I left a little space there? So I'm going to put a natural log here and a natural log here. Remember, that allows me to bring the exponent in front. T times what? Well, the natural log of e is 1, so it's like that. And all I got to do is go natural log, 62.5, 4.13. There, I solved t. Impossible to do without our good friends, the natural log. A few more. Last 2 problems. So we got this guy. So I know that some of you might go, 2 times 10, that's 20, because it's just sitting right out there. Well, let's take a look at something. 2 times 3 squared, let's do some math. 3 squared is 9. 9 times 2 is 18. So I know this is true. So So what if I multiply those two together and just tried it? Would 6 squared equal 18? No. So don't you dare think about going 2 times 10. But what you can do is divide by 2, divide by 2, 10 to the x equals 11 halves. Now I'm just going to go 10 to the x equals, I'm going to call that 5.5. I'm like, whoa, 10 to some power is 5.5? Good luck figuring that out. So I'm going to put a log on this side. I'm going to put a log on that side. And here we go. Bring that x into the front. So I get x times log of 10. Remember what this is? That equals 1. Type it in your calculator if you don't believe it. So that's 1x equals, now I got to go log of 5.5, 0.74. There you go. So that's what this is, and this. So, last problem. Very excited about these earthquake problems. I, again, didn't know about that formula. What is the magnitude? That's x. Nope. See how excited I am? That's m. Of an earthquake with seismic energy, that's x, of that many joules. So that's 3.2 times 10 to the 12th power. I wonder how they measure that. Did you ask yourself that question? So, equals 10 to the 1.5 magnitude plus 12. Again, this is a mess. I'm trying to find m. It's trapped up in the exponent. That's why I'm going to slap a log on this side. And I'm going to slap a log on this side. And then get to work. So log 3.2 times 10 to the 12th power, 12.505. I'll just go 12.5. Now, what do we do with this? We're going to bring it in the front. Front of what? Log of 10. What is that? That's 1. So 1.5 m plus 12 times 1 is not going to change. So I'm going to subtract 12, subtract 12. So I can get a 0.5 equals 1.5 m, divide by 1.5, divide by 1.5. So that's 0.5 divided by 1.5, that's 0.33. Okay, 0.33 magnitude. That's not a biggie. All right, get after that homework and have fun with it.